Hi everybody, today we're looking at lesson 5, making inferences from sample surveys. So you're going to learn how to estimate population parameters, analyze those parameters, and find margins of error. And one of the skills that's required is you're going to need to look at data and you're going to be able to pull some statistics for the data in order to help us solve some of these problems. So I know we've done this before, but just to make sure everybody remembers how to do it, this first page is about reminding you how to find the one variable statistics on a list of data. So you need your calculator ready to go here. And what we're going to do is we're going to do step 1 right here. We're going to go to stat edit and you're going to be entering all of these values into your list. All right. So, but before you do that, I would highly recommend that you do second plus sign, clear all lists, and just to make sure your calculator's all cleared out and ready to go. So do second plus sign, clear all lists, and then you're going to go to, like I said, you're going to go to stat, edit, and you're going to type in all those data values. All right. So I would pause the video right here, and when you're ready, restart it. Step 2, we're going to compute statistics on that list of data. So we're going to go to stat calc 1var stats. So once you've entered your data, you want to quit out of here. Okay. And then we're going to do just what it says in your notes. We're going to go to stat. So hit the stat button and the buttons will be highlighted in red. You're going to go over to calc and we're going to choose the top one variable statistics. And we're going to want to make sure this says list 1. So second 1, to make sure it says list 1 there. You're going to leave the frequency list blank. There shouldn't be anything there. And then you're going to say calculate. All right. And if you did it right, you're going to get a sum of your list of 145.8, and you're going to get a mean of 9.72. All right, so your screen should look like what I have right here on your notes. And then if you want to, you can get even more statistics from that list by pushing the down arrow. So let me go back to my calculator. Notice on your screen there's a down arrow, and you see the red button is now on the left of the screen. I can go down and I can get even more statistics on my data by pushing that arrow. Right, and I have at the bottom of the page here some of the more important statistics you can get when you run that one variable statistics. We get a sample size, gives you how many data values are in your list, right? Always check this first to guard against leaving out numbers or entering numbers by accident twice. We usually look at the sum of the list. We've been doing that throughout the year. When I give you a list of data, especially on an assessment, I tell you what the sum is. That's just a way of you being able to check that, again, you entered your data correctly. So the number of data items in this case should be 15, and the sum of the data should be 145.8. And when you do that one variable statistics, and let me circle this up here, right? That's going to give you your mean. That's going to give you your sum. This is our n, right? And those should match. Important statistics are obviously going to be the mean. That's the average of the data values. And there's 2 values they give you for standard deviation. We're usually going to be looking at this one because this one represents the sample standard deviation. So going back to this, we're going to be looking at that line for sample standard deviation. And our 5-number summary in this case, again, if you had scrolled down, given to you right here. So it gives you the minimum, gives you the maximum, the median, right? Gives you the quartile 1 and quartile 3. In case you were doing a box and whisker, you would use those as well. All right, so let's go to our notes. We're going to take down some vocabulary to start. And it says, the first one is descriptive statistics. Descriptive statistics involves the organization, summarization, and display of data. If you get even 100 pieces of data and it's all lumped in one big list, you really can't make sense of it until you try to organize it and summarize it and maybe display it in a certain table or in a box and whisker or something like that. Inferential statistics involves using a sample to draw conclusions about a population. It's not always reasonable to be able to poll an entire population and then, you know, make conclusions about that. You usually have to get a sample. So if I wanted to know how many seniors in high school drive their own car to school, and I needed to really know about the entire country, how many seniors drive their own car to school, I wouldn't be able to poll every single senior in high school in the entire country. So maybe I would pick a couple of high schools in New Jersey and poll them, and then based on those results, I could make some assumptions about the rest of the country. All right, so example A says the number of friends for a random sample of 40 teen users of social networking website are shown in the table. Estimate the population mean. All right, so you're not going to like me very much right now because what I need you to do is I need you to enter all of this data into list one into your calculator. So you're going to enter all these values and then you're going to keep going. These aren't in separate lists. These are all going to be entered into list one, n equals 40. Right, so you're going to go ahead and do that. Pause the video right here and then join me when you've entered your data. Okay, so here we are in list one and everything should be entered. And when you're ready, you're going to quit out of the list and we're going to do our stat calc one var stats, stat calc one var stats. Everything should be in list one and calculate. And if you did it correctly, you should get a sum of your list of 11,966. So let's just make a note here. Sum of x is equal to 11,966. So that's the first thing. We want to make sure you entered the data correctly, right? And they want to know, what does the population mean? Estimate the population mean based on the sample mean of this data. All right, well, x bar, that represents our sample mean. All right, so we're going to go back to our data in our calculator. X bar is 299.15. What other information does one var stats give you? All right, well, there's a lot of information there. We'll write down a few items. We've got our min, we've got our Q1, our median, our Q3, and our max. And then we'll also do our sample standard deviation. So let's go back to the calculator. All right, so you can see right on this screen that the sample standard deviation is 61.08. I'm going to write that guy in. And if I scroll down, I can get the rest of the information. I just want to have that all on the screen here. So my minimum is 150. Q1 is 258.5, median is 299, Q3 is 342, and the max is 445. So let's write those in. Now, we're going to construct a histogram with our data. So we're going to turn stat plot on. So we're going to go to second y equals, and we're going to make sure that that says on. We're going to make sure that we've selected the histogram, the bar gram. We want our X list to be list one, and we want our frequency to be 1. All right, and then in order to see this, we want to zoom statistics. So we're going to do zoom 9 for zoom statistics, and we'll get a very nice picture of our histogram. So if I went a little too fast, just pause, rewind it, watch it again. Make sure you can get this on your calculator. So we're going to just do a sketch of what we have there. All right. We had one bar that was about here. We're not going to go crazy here and make it too perfect, but generally this is what we saw on our screen. And we'll just do a little line over it just to give us an idea of what the shape of that graph is. And that graph looks pretty symmetric to me. All right, so we did a lot with that set of data. We're going to do the same idea with the next page. So again, when you're ready, I would say clear your list, second plus sign, number 4. And then we're going to go ahead and enter the data in for the next problem here. You're going to enter all of that data into list 1. So when you're ready, pause the video here. When you're ready, restart it. All right, so all of your data should be entered here. I'm going to quit out of my list. I'm going to run one variable statistics. And if you entered your data correctly, for the population mean, you should have gotten 294. Well, it's the sample mean, which we estimate is the population mean. And the sum of your list should have been 8820. So let's write those down. Right, so this is, again, from 30 teen users of a social networking website, right, and how many friends they have. So we are estimating that for the whole population of teen users, most people have, in this particular social networking website, 294 friends. Now, we also want to construct a histogram. So I'm just going to show you again that you should do stat plot on. If you've already done this, you don't have to do it again. From here, if everything matches, you're going to do zoom 9. You have to do zoom 9 to see your new histogram, and then we'll sketch that out on our notes. And we'll draw our line that gives us a sense for what the shape is. And this guy also looks symmetric to me. Right now, larger samples tend to produce more accurate results. We only have 30 teenagers in this particular one. So with that, that's not very many people. We probably need more like 3,000 to feel really confident that on average, most people have, whatever our sample mean says. All right, let's take a look at the next example. A student newspaper wants to predict the winner of a city's mayoral election. 2 candidates, A and B, are running for office. 8 staff members conduct surveys of randomly selected residents. The residents are asked why they will either vote for candidate A. The results are shown in the table below. Right, so what I would say here is just to pause the video, see what you think, and then when you're ready, hit the play button and see if you got what I got. So letter A says, based on the results of the first 2 sample surveys, do you think candidate A will win the election? Right. Well, the results of the first 2 surveys, our sizes 5 and 12, show that fewer than 50% of the residents will vote for candidate A. Because there are only 2 candidates, one candidate needs more than 50% of the votes. So based on these surveys, you can predict candidate A will not win the election. All right, because again, let me just highlight that for you. We're just talking about this. And there's only 2 people, so these guys should be higher than 50% if we were expecting candidate A to win. All right, letter B, based on the results in the table, do you think candidate A will win the election? So based on now the entire table. Well, as the sample size increases, right, as we look here and we get bigger and bigger and bigger, the estimated percent of votes approaches 59%. So the more people we get in the survey, this percentage over here is getting closer and closer. It looks like, it's almost 58, then it's 58, then it's a little over 58, then it's almost 59, then it's at 59. So we're approaching, 59%, 60%. So based on the whole table, we do believe that candidate A will win the election. Okay, great. In example C, a national polling company claims 34% of U.S. adults say mathematics is the most valuable school subject in their lives. You survey a random sample of 50 adults. What can you conclude about the accuracy of the claim that the population proportion is 0.34 when 15 adults in your survey say mathematics is the most valuable subject? All right, so we're going to be using this frequency chart here. I'm going to answer this right here. So first of all, we're talking about 15 out of 50. And 15 out of 50 decimal is 0.3. So we're looking right here. And with this frequency chart, the more frequent it is, the more dots that are in that column, that makes us believe it's more likely. The less dots, not so likely. So according to our frequency diagram here, we would say that the company's claim is probably accurate. All right, so letter B. What can you conclude about the accuracy of the claim when 25 adults in your survey say math is the most valuable subject? All right, well, 25 out of 50, that gives us 0.5. Oh, 0.5 is over here. Only one dot there, all right? So in that case, if that was the case, I would conclude the company's claim is probably not accurate. All right, and the last one is a little bit more of a complex question. It says, assume that the true population proportion is 0.34, right? Estimate the variation among sample proportions using the sample size of 50. All right, well, we're assuming that the mean is 0.34, right? And if we go back to lesson 1, and I just want to bring up that formula sheet that I gave you. When we're talking about lesson 1, we know that 99.7% lie between the mean plus or minus 3 standard deviations. So that means that we would expect the range of data to go plus or minus 3 standard deviations for 99.7%. So minus 1 standard deviation, minus 2, minus 3, plus 1, plus 2, plus 3. All right, so we're expecting our data mostly to occur, right? And I'm just going to say for letter C, I'm expecting 99.7% is between 0.22 and 0.46. Right, that one's a little tough. I'm really more interested in just exposing you to this. I don't know that I would put a question like letter C on a quiz or a test. That's a little tricky. All right, but letter A and B are pretty fair, and hopefully I was clear in explaining those. All right, let's take a look at our last page here. Margin of error for surveys. When conducting a survey, you need to make the size of your sample large enough so that it is accurately representing the population. As the sample size increases, the margin of error decreases. So the formula for margin of error, and that is on your formula sheet. I'll show you, it's right here. It's plus or minus 1 over root n. So let's write that on our notes. N represents the size of the sample. In a survey of 2,048 people in the US, 55% said that television is their main source of news. What is the margin of error for the survey? So we're going to write plus or minus 1 over the size of the sample. If you do that in your calculator, you're going to get plus or minus 0.022, which represents plus or minus, if we move the decimal 2 to the right, 2.2%. Let's keep it in terms of percent. It makes more sense in context of the problem. Given an interval that is likely to contain the exact percent of all people who use television as their main source of news. All right, so we're going to take what they're saying is the population mean. All right, and that would be 55. And we're going to subtract 2.2%, and we're going to add 2.2%. That gives us an interval of what we expect the population to be. So instead of just telling you what the mean is, we're saying we're pretty confident that most of the people within this range are using television as their main source of news. So 55 minus 2.2 is 52.8%. And 55% plus 2.2 is 57.2%. So when you're asked for an interval, that's what we're going to be doing. Subtract from the mean and add to the mean. In a survey of 1,028 people, 87% reported using the internet. All right, so you have two questions here. I would suggest pausing the video and then restarting after you've tried to answer them. In this case, the margin of error is going to be 1 over root 1028, which gives us plus or minus 0.031, which gives us 3.1%. Give an interval that is likely to contain the exact percent of all people in the US who use the internet. We're going to take our population mean, subtract our margin of error, population mean, and add our margin of error. And we're going to get 83.9% and 90.1%. That would be the interval. Okay, everybody, that's all I have for today. Thanks for watching. Have a great day.